Hello everyone, this is Saji again. Today we're going to look rigid transformation. What is rigid transformation? Anyone? Rigid transformation is you're going to move a figure or shape anywhere, but it does not going to change in a size or shape. That's what's called rigid transformation. Let's see. Is this a rigid transformation? Let's look at it. This looks like a little square with the bolt on the corners or vertex. And then it comes over here. It does look like what it is. It's look like a rhombus. Do you think square and a rhombus are same? Not really. The shapes change. Even though the sides looks the same, the shape change. If you look at this angle, it's more than 90 degrees. In here, all four angles are 90 degrees. So this is not a rigid motion. How about here? This triangle moved from here to here. Does it change in a shape or size? It does not. So it is a rigid motion. How about in here? It's exactly the same shape, but look at the size. This is bigger than this. So this is not a rigid motion. Changing figures. How can things change without changing size and angles? Which is they are talking about if it's in a figure, is there an angle? That's the angle they are talking about. Basically, you can say, how can we change? How can we change or move a figure without changing the shape or size? One thing you can move it, which is translate from one place to another. Left, right, up, down, which is called translation. Or spin it, rotate it. That's called rotation. Or you can flip it. Or mirror image, which is reflection. So if you put one side and it's going to look, when you put on the other side, it's going to reflect. That's called mirror image or reflection. Coordinate plane, two number lines. What are two number lines? Which is you see horizontally, like this way, which is called x-axis. The other one vertically, which is y-axis. All right. And then you have every point has a coordinate, x comma y. I believe the second or first video we were looking at the point. I believe the first video, when you locate a point, we write the location in a coordinate plane, x comma y. So this is x value is 2 comma y, which is 3. And here -4 comma 5. Same thing over here, -3 comma 3. This is the x value, the last one is the y value. The first one is the x value, the last one is the y value. Please remember that. First thing, it's a translation. Like I said, you are moving a figure in one direction, either up or down or left or right. That's called translation. All right. We will talk about this one later on down the road. Don't worry about it. But we will look into it later on. Rotation, spinning the figure. Let's say, you have a point and you rotate it, circle, or like a half circle or quarter circle or portion of a circle, which is called rotation. So when you rotate, what do we relate it to? degrees, 90 degrees, 180, 270. Reflection, mirror image, or mirror image of a figure over a line. So if we have one image, and if you put a mirror right in front of it, how does it gonna look on the mirror? We will show some examples in next class, but just try to understand or try to think about it, what is mirror reflection or reflection, all right? If you have any question, please feel free to come to office hours or give me a text and then set up an office hours. Rigid transformation of geometric figures take one point at a time. Basically, when you transform or rotate, the easy way to do it, instead of like finding like random points, take the vertex points, take the corner points, and then move those points according to the direction. Let's see, watch this video. This is the brain break, and let's look at it. How does it look? It's nothing related to math, but it's a good video that you can look into it.
As we grow older, we often lose the extreme ends of our hearing spectrum. So, how many of the following sounds can you hear? How old are your ears? Okay, if you can hear 8,000 hertz, you're both alive and not hearing impaired. But let's keep raising the frequency. How high could you hear? If you could hear all of those frequencies, you're probably under 20 years old, but that won't last forever. Unlike other organs such as the liver or skin, the inner ear does not have the capacity to regenerate. In your ear, there are thousands of tiny nerve cells called hair cells. These are responsible for picking up different frequencies and sending the signal to the brain where it's processed. But as you age, the continual exposure to noise and loud sounds can break, bend, and destroy these cells. So why do the high frequencies go first? It turns out that the hairs tuned to high pitches are the first to encounter sound waves. As a result, they experience more stress and tend to degenerate earlier, which is why the older you are, the harder it is to hear high pitches. Got a burning question you want answered?
So this is just a brain break. I hope you enjoyed, and let me know if you have any questions or concern. Thank you.